Who figured out the answer to this question? Yes. How did you find that? That's right. You just plug them in. A system of equations is just multiple systems. Now, in this case, they're both lines. Anytime you have two variables, it forms a line. So what this was saying is, do these two lines intersect at this common point? Because that's the only possible way that a point could lie on both lines, unless, of course, they were the same line. So what you had to do was plug them into both equations and see if it made it work, and they did. 2 plus 3 times 3 is 11. You know how to plug stuff in. So you plug it into both, and they both equal. We are going to be spending the next 2 days on systems of equations, both in 2 variable today and 3 variable tomorrow. And that'll be leading up to a much deeper section we're going to do on matrices. So that's why if you're thinking, I did this in Geometry and Algebra 2, it's review, because you're definitely going to need it for our... Okay, that's awesome. Then it should be very easy for you. Then it'll make the matrix section much easier to comprehend. We're going to solve systems of equations by a variety of methods. The first one we're going to look at is a substitution method. Now, when I say solve, I mean find that coordinate. It's not going to be provided for you after the first problem or two in today's assignment. The first problem will be like the one we just did. It'll say, here's a point, is the solution, you plug it in. The rest of them are going to say, solve the system of equations. Now, substitution method. We're going to look at number 5. If you can solve for one of the variables, here, y equals 3x, you're going to substitute that, hence the name, into the other equation. So that's x, y equals 3x. So I'm going to plug in 3x equals 4. I plug this in for that y. That's 4x equals 4. Divide by the 4. X equals 1. Okay. Plug 1 in for the x into either equation. Looks like Troy did it for this one really quickly and got y equals 3. And that ordered pair is the solution to that system of equations. Now, the book is going to tell you, use substitution method, use elimination method. I don't care which method you use, since I'm about to teach you multiple ways. What I do is, anytime one of the variables is already solved for, like x equals or y equals is already like that, I think it's a good time to use substitution, because you don't have to solve for anything. You can just plug it right in. If you notice, 7, 9, both of those have something, a variable equals. A variable equals. So you don't have to do anything except for go ahead and plug it right in. Let's look at number 11. No, excuse me, number 9. Which one do you want to use? The top one or the bottom one? Either one. Top one it is. We're going to plug this in for the x on this equation. So that's 4y minus 2 equals 6y plus 8. Because we plug this in for this x. Subtract. Minus the 4y. That's a y. Subtract the 8. Divide by 2. And y equals negative 5. Oh, by the way. This was a... Okay. Yeah, I don't think that's true at all. I think you made that up. Anyway. Okay. That's the substitution method. All right. Let's see. The hardest thing you should have to do with substitution might be fractions. So like number 17 here. So when you have to set two fractions equal to each other, because we're going to let this plug what this y equals in for here. So that's 1/3 x plus 2/3 equals 5/7 x minus 2. Now, when I was a young boy, I was taught that anytime I had a whole bunch of different fractions, it's easiest just to knock them all out at once by multiplying the whole thing by a common denominator. What is the common denominator here? What is the number that both 3 and 7 go into? 21. Let's multiply the whole thing by 21. So 21 times every single piece. 21 times this, 21 over 3 is 7x. 21 times 2/3 is 14. 21 times 5/7 is 15x. 21 times negative 2 is negative 42. So now we've gotten rid of... Oh, that's what I need to do. Now, there we go. We've gotten rid of those pesky fractions and we can solve this thing. Minus 7x minus 7x, that's 14 equals 8x minus 42. Add the 42 to the other side. Divide by 8. And x equals 7. Plug it back in. Ooh, this one looks convenient to plug that into. Y equals 5/7 times 7 minus 2. So that's 5 minus 2, and y is 3. 7, comma 3 is your solution. If you run into fractions, knock them all out at once by multiplying by your common denominator. Questions on that guy? Can I what? I can. The other way I'm going to show you is elimination method. The elimination method is based on the fact that we are looking for a common point that these two equations have. So assuming that for at least one spot these two equations are equal, then by that rationale we should be able to just add them together and not change them if they're already equal to each other. So we're going to be doing the elimination method is manipulating these equations so that when we add them together, one of our variables poof, goes away. Are you good, Austin? Excuse me? I'm sorry, I was joking. Okay, so now 21 and 19 are ideal elimination, or I guess they call them addition method. I always call them elimination. Are ideal addition or elimination method problems because if you notice, if we were to add these two equations directly as they are, one of the variables would just go away. If we added those two equations as they were, that'd be 2x, the y's would cancel, equals 4. Which would make x equals to 2, and you could then therefore plug it in and solve for y. When I say plug it in, I mean either equation and solve for y. Same thing with 21. If we added those equations the way they... Hold on, let me regain myself. If we added those equations the way they were, the y's would cancel again. That'd be 4x equals 12, solve for x. Addition method, you literally add them together. 23, will that same thing still be the case? No. But one thing you can do, just like, you need to remember that all these represent lines. So like you take the line y equals 2x plus 3, that is a slope of 2, y-intercept of 3. If you multiply that whole equation by like 4, you get 4y equals 8x plus 12, and you haven't changed the line at all. This line still has a slope of 2 and a y-intercept of 3 when you redivide it. So by that logic, you can multiply anything you want by these equations as long as you do it by both sides. So what you're going to need to do is look for something that you could easily multiply your equation by that would cancel one of its variables. For instance, what do you think I can multiply this top equation by that would nicely cancel it with something on the bottom? 4. That would make it 4x plus 8y plus equals 8 over negative 4x plus 3y equals 25. Now if we add them together, we get 11y equals 33, y equals 3. And if we go back and plug that in, I'll plug it into the top one over here. That would give us x plus 6 equals 2. Subtract the 6, and x equals negative 4. So that would be my solution. I personally prefer to always multiply by something of a different sign. Like on number 25, the y's have different signs, so it makes the most sense to multiply by there. Here the y's do again. But you don't have to, because you can multiply by negative numbers as well. 25, now unless I want to multiply by a fraction, I can't just multiply one side of the equation. So I'm going to multiply both equations by something. Or we could do that. Excellent. See, my first inclination, this is an important note. You can work these problems in any number of ways. That's important to know because, like, let's say you say, oh, I didn't get the right answer. And you look up at my work, and I might work at solving for the y value. And you're going to think, well, I must have messed up because I was looking for the x. No. These can be worked so many ways that a lot of your work is going to look different. That doesn't make it wrong. For instance, Josh just said, quite correctly, why don't you just multiply the bottom row by negative 2? That would cancel the x's, and we will. I personally would have multiplied the top row by 5 and the bottom row by 3 to get rid of my y's, because I just like to avoid multiplying by negatives. But he has no such fear, so we're just going to do it his way. Negative 4x plus 10y equals negative 2. That's this with the negative 2 multiplied through. Adding that to the top row, 4x minus 4x is 0x. 3y plus 10y is 13y. 15 plus negative 2 is 13. Hey! Nice and neat. So y equals 1. Come back up here and plug it in. So it's 2x minus 5 times 1 equals 1. Add the 5. Technically speaking, to check and see if your answer is correct, you need to do the same thing you did in the DOM and plug it into both equations and see if it works, and it should. I'm not going to do that every problem just because I trust the math that I'm doing, and I hope you will as well. But if you ever don't feel good about an answer, plug it into both. And if it works for both, you did it right. Questions about that problem? This is 7.1. 7.1. No questions? All right. Is there another problem on this page somebody would like to see? Because it looks, well, there's only one left on this page, isn't there? Does anybody want to see number 27? Okay. Solve using the method of your choice. Now, again, number of ways you can do this. You might want to use elimination method on 31. I see a variable that's already solved for, so I think substitution. Doesn't matter. Look up here and raise your hand and tell me which of these problems would you like to see work. They're going to be the exact same thing we already did, choosing whatever we want to do. Yes, ma'am. 33. Okay. How would you prefer to work this? Well, see, I would go with substitution because one of my things is already solved for. But you don't have to. If you go with substitution, I'm going to plug this in for this y. So that gives me 21x minus 35 equals 7 times 3x minus 5. 21x minus 35 equals 21x minus 35. Dun, 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 dun. What is happening? I'll show you. Subtract 21x from both sides, you get negative 35 equals negative 35. Add 35 to both sides, and you get 0 equals 0. This is an interesting situation. Way back here, I mentioned, I knew I'd do it. I mentioned that every time you find an answer to these systems, so in this case 2, 3, that is where these lines cross. If you ever get something that everything cancels, and you're left with 0 equals 0, that means you have the same line right on top of itself. So there's infinitely many solutions. If we go back, I bet we can almost see that. Yeah, this one has a slope of 3 and a y-intercept of negative 5, and this is the same exact equation, just multiplied through by 7. So that's why we got this. So the actual answer here is infinitely many solutions. Infinite solutions. Yes, ma'am. No. I guess you can. They're just lines. You can, if you'd like. You don't have to. You could graph them and then eyeball it and say, but that's the answer. That's fine. I don't care how you work them. So this, I think this is quicker. So I'm glad that one came up. Now, what if everything had been the same except this side had been, remember this is just a what if scenario, 36. So you get like negative 1 equals 0. If everything cancels and you get a false statement, that means your two lines are parallel and therefore have no solution. So if you get a false statement, no solution. A true statement, 0 equals 0, means infinitely many solutions. So remember that. That'll be helpful. False statement, no solution. True statement, infinitely many solutions. Is there another one on this page that somebody would like to see worked? I bet there is. People are just not wanting to ask. I would love to do 39. I was hoping somebody would ask me for that one. 39. Do I want to do 39? What a way to word that. I dreamt of 39. Okay, now, I told you earlier, whenever you have fractions, what's the easiest way to get rid of them? By the common... What would that be in this case, Shelby? We could do 16, but actually, since they're the same, just do the 4. Multiply the whole top row by 4. I'll write it down here. That'll give you x minus y equals negative 4. Now, I'm looking at this system. What's something I could multiply one of those rows by so that something will cancel? Anybody? I could multiply one of them by negative 1 and the x's would cancel. I could multiply this one by 4 and the y's would cancel, but I heard negative 1 first, so that's what we'll do. Top or bottom? Top. Multiply negative 1 by the top one. I'll write that down there. And you get negative x minus 4y equals 9. Now we can do the addition method. Cancel. Negative 5y, 5. So y equals negative 1. Come back up here and plug it in. I'll plug it into the bottom one. X plus 4 times negative 1 equals negative 9. Add the negative 4, and you should get negative 5. So negative 5, negative 1 is your solution. Yes. Questions on that problem? Zach, you look really interested by this. Any other questions from this page somebody would like to see work? I can. Now, let me throw this warning out there. Only half of you are going to heed this warning. We're going to be doing these in 3 and then 4 variables. We could go further, but we're going to stop at 4. I'm not going to say it's going to take forever, but it's going to, well, yeah, they're going to take forever. And it's going to take up a lot of space on your paper. And you're going to get all the way to the end sometimes, and then one negative number will be wrong. And you'll know you're wrong, because we'll go over ways tomorrow where you're going to learn to notice if you're wrong. And it's going to be very hard to diagnose where you went wrong if you don't show some work on these. I'm not requiring it, but I can't tell you how often somebody will punch their desk because they'll spend an hour on a 4-variable problem. Yeah, some of them take a long time. And they'll get all the way to the end, and one negative will be wrong. They're like, where did I go wrong? I'm like, let me see your work. Well, I was erasing it as I went. That means you have to start all over, and it can get very aggravating. So, please, 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 show some work on these so that if you make a mistake, we can diagnose it so you don't have to start all over again. Okay. Ooh, these are fun. Number 43. The sum of two numbers is 7. Sum of two numbers. Let's call one of them x and the other one y. If one number is subtracted from the other, minus y, their difference is negative 1. Find the numbers. You create your own system, and from here I'm trusting you could solve it. Just add them together. You have to create your own system of equations giving the words. 45. Take a look at that one, and then I'll take a volunteer to tell me what my system would be. Shelby. 3 times a number decreased by a second number equals what? Okay, keep going. Well, it says the first number increased by twice the second number. There you go. Equals 12. There's your system. And then solve that one. Again, you need to solve from here. I'm trusting you can do that. Questions on that problem? Last one. I can't wait to hear the groans. Oh, the groans. How generic of a groan. Okay, here we go. We have to create our own problem. For thousands of years, gold has been considered one of Earth's most precious metals. 100% pure gold is 24 karat gold, which is too soft and too feed. Okay, so most gold jewelry is 14 karat and approximately 58% actual gold. If 18 karat gold is 75% and 12 karat gold is 50%, how much of each should be made to make 14 karat bracelet weighing 300 grams? Anybody think you have a theory about how we're going to set this up? Yes, you're going to have one like this today in your homework. Excuse me? Okay. Don't do that. It's not that hard, people. Although I'm looking at it and drawing a blank, but it'll come to me. Most gold jewelry is 58% gold. Check. Now, I think the whole trick here is to come up with the actual quantities. If 18 karat gold is 75% and 12 karat is 50%, how much of each would you have to make 14 karat of 300 grams? How much actual gold is in a 300 gram 14 karat bracelet? 58%. Very good. So, what's 58% of 300, someone? Calculator. I'll race you. 1, 7, 4. No one's racing me? No one's punching this in the calculator? 174 sounds good to me. Nobody cares anyway. So, we are adding the two things together and getting 174. Okay? That's pure gold. But how much of this are we getting? Well, originally we were using 75% of the 18 karat. So 0.75, I'll use fractions. 3/4 of the 18 karat and 50% of the 12 karat. And how many total grammages of gold are we ending up with? 300. And there would be your system. Yes, there would be your system. Practicing a skill. This may not be a perfect real-world application for it. Anyway, you get to here, multiply the bottom one by a common denominator and solve it. Let's finish it. What's the common denominator on the bottom one? 4. So that's going to give me 3x plus 2y equals 1200. Now I can put that with the top system. We'll call this the pure gold and the carats of gold. How should I solve this? Elimination sounds good to me too. What would you multiply something by, Troyan? -2 by the top one. So that gives me -2x minus 2y equals 348, -348. By the way, did you guys finish Sherlock this weekend?
No.
Oh, you didn't see him die? That's fell asleep. You're not worthy of Sherlock. So that's 852. I do go too far. So if x is 8, well, that can't be right. That can't be right at all. We're solving for x and y, dude.
Yeah, we're still together.
What? Oh, come on. We're right there at doorstep. I'm going to finish this on my own time. And I'll let you know what the answer was. You know what?